Okay, so remember that logarithms are just exponents, and if you keep in mind that fact, then a lot of these properties I'm going to talk about will make sense. Now, the first formula we're going to look at is one of the most useful formulas, and that's called the change of base. And what it says is if I have a log of some value x with base a, then I can convert that to a ratio of logs with a different base. Okay? And the way I do that is I do the log of x with the base I want divided by the log of my original base to the base I want. Now, because calculators work with common base 10 and natural base e logs, we most often use these versions of the change of base formula. We can go from a log x base a to a log x divided by a log a, or we can do a natural log of x divided by a natural log of a. And I'll show you how we can use this. Let's say you need to evaluate the log of 20 base 3. So we don't have a base 3 log button on our calculator. However, there we go. However, we can convert this to a ratio of common logs. So I'm going to go log 20. Make sure you close the parentheses because you want to divide that entire log, not just the 20. Log 20 divided by log 3. Close parentheses, and we get 2.7268. And the cool thing is it doesn't matter if I use common logs or natural logs. So let me do the same thing with natural logs. Natural log of 20 divided by the natural log of 3. And we get the same thing. Okay, so that's how you use the change of base formula with your calculator. Okay, and then we have these three important properties of logarithms: the product property, the quotient property, and the power property. So the product property says that if I have the log of a product, I can split that up into two logs that are added together. So the log of u times v is equal to the log of u plus the log of v. And it doesn't matter what base we're working with, if it's a or e or 10 or whatever. The quotient property says that if I have a log of u divided by v, I can convert that to the difference of logs. So that would equal the log of u minus the log of v. And finally, if I have the log of u raised to a power n, that power can come around front and become a factor that's multiplied. So it's n times the log of u base a. Now, you may be wondering, how am I going to remember all this stuff? Well, don't forget, logarithms are exponents. And so what happens if I have x to the a, or let's use the same letters they do. What happens if I have x to the u times x to the v? What do we do when we multiply terms? We add the exponents. And since logarithms are exponents, when I'm multiplying terms, I'm going to add the logarithms. If I have x to the u divided by x to the v, when we divide terms, we subtract exponents. Guess what? When we take the log of a quotient, we subtract the logs. And finally, if I have a term raised to a power, what do we do with those exponents there? We multiply them. So guess what? When I have the log of something raised to a power, that power gets multiplied times the log. So these properties of logarithms are exactly the same as the properties of exponents. Now we can use these properties to expand and condense logarithmic expressions. For example, let's say we want to expand the log of x to the fourth times the square root of y over z cubed base 2. Okay, x to the fourth is being multiplied by that square root, so I can convert that into an addition. And I'm going to change that radical to an exponent. Now this 4 can come around front, and this 1/2 can come around front, That should be z cubed, shouldn't it? And finally, I have 4 log x base 4 plus 1/2 log y. Well, that's base 2, I'm sorry. Base 2, and that's base 2. And that's base 2. Y base 2 minus 3 log z base 2. And our final answer will look like this. Okay? So that's expanding a logarithmic expression. If they're already expanded and I'd like to condense it into one log, I just do the rules backwards. So this will be the log of x cubed plus the log of y to the 4th minus the log of z to the 4th. And since I'm adding these two logs, that will become a product. And I'm subtracting that log, so it is being divided. And so now I've condensed it into a single logarithm. Okay, last type of problem. What if we know the log of 2 base b is this number, the log of 3 base b is that number, and the log of 5 base b is that number? Can I figure out from these 3 facts what the log of 10 base b is? Yeah, we sure can. That's going to be the log of 2 times 5 base b, which is the log of 2 base b plus the log of 5 base b, which is 0.2891 plus 0.6712, which is 0.2891 plus 0.6712, 0.9603. How about the log of 2.5? Well, that is the log of 5 divided by 2 base b. So that's the log of 5 base b minus the log of 2 base b, which is equal to 0.6712 minus 0.2891 and we get 0.3821. Okay, how about this one? The log of the square root of 3b cubed base b. So that will be 1/2 the log of 3b cubed base b. Now, do you know where that 1/2 came from? I turned the radical into an exponent of 3b cubed raised to the 1/2, and then I moved the 1/2 around front. Okay? That's going to be 1/2 the log of 3 base b minus, or plus rather, the log of b cubed base b. So that's 1/2, and up here log of 3 is 0.4582, 0.4582, and from a previous property that we learned, the log of b cubed base b is 3. So that's 1/2 of 3.4582. Let's work that out. 0.5 times 3.4582. 1.7291. All right. Have fun applying these properties of logarithms.